actuators, about microcontrollers. Now we are going to focus on two different specialized things. The first specialized thing is a PLC. So PLC stands for the Programmable Logic Controller. As the name suggests, it means that this guy does something about logic. And also this guy is programmable. Programmable means that you can have different applications for this guy. So keep in mind, so PLC is not very highly sophisticated. I should not say that. So PLC should not be scary for us. PLC is just a specialized microcontroller. You understand that? It is just a specialized microcontroller, just as industrial robot. Industrial robot, the central part is still just a microcontroller. And just don't be scared. So objectives, and we want to familiarize ourselves with PLCs and their classification. And we want to know the advantages of PLCs and where we use PLC, at what time did the PLC appear in our in industry. And we want to understand the architecture of PLC. As I said, PLC is a specialized microcontroller. When we compare this guy's architecture, we will find that this architecture is very similar to the architecture we talk about for the general microcontrollers. And we understand inputs and outputs, and so this is nothing is new. Understand the methods of processing inputs and their impact on the program. Questions regarding this slide? So keep in mind, PLC is just a specialized microcontroller. So that means it has input, output, and you need to program, and you need to wear them. You need to test and design the program and test it. So here, so look at this diagram. So this is a box. We say the PLC. The input is input from devices. So this is sensors, and the input signals from the sensors. So these sensors can be analog sensors or can be digital sensors. And here, before my PLC works, I will download the control program to here. Okay? You understand, guys? Just like our human, a human being. Before we handle something, and we must learn some knowledge. You guys agree? Learn some knowledge. And for example, mechanical engineer guys, they are thinking kind of different from other disciplines. So our goal is to design and build things and to improve our daily life and to benefit our society, our country. You guys agree? So first, you need to learn something, and then you have you found this input and output, and then you can do something. The same thing here. So first, you design a program on what is your application. You just write a program, download it, and then wire the system to the inputs and outputs. Then whenever these inputs, these input signals are fed to this PLC. So this microcontroller will go through your control program that you have downloaded, and then determine on what kind of actions will be taken. You understand? First, we learn something, and then we get the data from outside, and then we just process this data based on what we have learned, and then we take action. Same thing. On PLC, the classifications, the advantages. Okay. And before PLC, guys, and we use control relay, I want you guys to write down our first lab will be handling the control relay. We use the control relay, and control relay means if some condition is met, or we want to do something they call control relay. So the flexibility of this PLC is replace hardware automation, easy to program. Okay. easy to program, flexibility, robust, and designed to withstand vibrations, temperature, and humidity and noise, hence increase reliability. It minimizes logic wear errors. And before the PLC appeared, and people use the control relays and a lot of wears. You wear the system, use your hand, use this physical wear, the hardware. This is the things, the wear, and put things together. It's very, very easy to make errors. So this for the PLC. All this is manipulation will be carried out in the microcontroller. So as a result, it's very, very robust. So the speed and PLC are designed for high speed and real-time application, right? So the speed of PLC is, we can just generally speaking, we can see it is as fast as light, as long as for this for the signal processing. I'm not talking about driving things. When this guy drives the mechanical things, that's another story. Okay, I'm talking about the data processing, because electrical is all the electrical thing. Right? So the communication with operator is very easy. Okay, it's very easy. You write a program. It's very easy for you to diagnose what's wrong with your program and how to test this one before you put this guy into application. Diagnostics is what I just said. So advanced functions. So control relays. The precursor of this is the PLC. This guy has never ever had the computation and the control task. Right? But the PLC we have. And PLC, as I said, PLC is a specialized microcontroller, and this guy can do the computation and can calculate the things, multiply things, and divide things, do these division things, or do a lot of things. The cost effective for complex system. The more complex system you have, the better for you to use PLC. Okay, it's worthwhile to spend thousands of dollars more and to buy a PLC instead of use many control relays and a lot of wires and for your system. If you do this way, and you will be very, very confused later. Questions regarding the advantages? That's the reason in later 1960s, the PLC appeared, and also because application, industrial application, automation, industrial automation drove this PLC. So PLC classifications, or we can have micro, small, medium, large, and based on these inputs, okay? Micro PLC, we have 32 inputs, less than $500, and 1K of memory. SLC smaller, we have more inputs, medium, more, larger, more. And independent high-speed counter with direct actuator control is available. So when we buy PLC, and we can also buy these kind of counters as well. So whenever we talk about microcontroller and the counters and timers are often used. Can you guys write down? Counters, timers. Almost all microcontrollers, they have their own timers and counters. So this is architecture of PLC, right? So the architecture of PLC, and you can just recall your memory, recall what is architecture looks like for a general microcontroller. And we can see program panel, and we can see this is the CPU. We have CPU. And we have a clock, which is used to synchronize all these components. And the ROM, data ROM, input and output units. The user program RAM, the battery. Battery is always there. Okay, without battery, what will happen? Without battery, and you cannot. What's the function of battery? Without battery, so this is system ROM will disappear. So we have address bus and control bus. And so this L system bus So for this is the input channel, and opto coupler buffer, and this is a system bus, output latch, driver interface, drivers. And so here is one new concept, opto coupler. Write down as opto coupler. Okay, so whenever you see this opto, what comes into your mind, guys?
8.
Huh?
8. Like the number 8. Oh no, it's octo. Never mind.
Yeah. That's in the number system in that context. That is. Another one, opto. Whenever you see opto, guys, what comes into mind?
Vision,
Huh?
seeing, like optics, like seeing stuff.
Yeah, seeing stuff, light, right?
Yeah.
Yeah, light, right? Nico, you are right. Cool. This depends upon context. Optical here means that we use the light and to couple two different things. Can you write down this? I love you so much. I just want you guys write down these new things. Whenever we see new things, we write down because other things we already know. New things, when we take care of these new things more, that means we are pushing the frontier of our knowledge. You guys agree? Optocoupler, it means that and we use the light and to couple two things. And why we need to use light to couple two things? And because write down, I want you guys to write down, okay? Because PLC is driven by very, very low voltage. 5 volts, 12 volts, maybe 36 volts. However, so PLC is driving the devices, sometimes might be 110, our daily life, this appliance, and maybe this is 240. Right? So we do not want these two systems to be connected together physically. And what we should do, and we use optical coupler. Optical coupler means that, so these two guys, low voltage system, high voltage system, these two guys, they are coupled using the light. Okay? So that means whenever something goes wrong with this is the high voltage appliance, and the high voltage will not come back to my low voltage circuit and to ruin my PLC system. You understand that? Coupler, just cut it off. These two guys are connected, not physically, but using the light. So definitely you need to buy this optical coupler. So there's some companies, they are providing this kind of the products. I will ask you guys, what is the coupler, optical coupler? Why we need an optical coupler? The answer I'm expecting is low voltage system, high voltage system. We do not want them to physically connect together. We want them to be connected using light. So this is what I just talked about. Right? So the battery prevents the loss of program. It's very around. So clock, the synchronize everything. The inputs. The inputs. So the input circuitry, and input circuitry filter on the field signals. Field signal I'm talking about in the plants. In this is the factory, the plants, machine shop. To validate the inputs, the validity is determined based on its duration. I also want to underscore this one, okay? And how the PLC knows that this signal is a valid signal or just a background noise. It depends upon the duration. So they wait to confirm that a signal is a reference from an input device rather than electrical noise. And typical filter time is 8 microseconds. So this is a threshold value. Right? If you use this one when you program, and mainly you can just filter most of this background noise. So input and output channels provide isolation function. So this is what I told you guys, okay? Therefore, sensors and actuators are directly connected to them. So the channel within this input channel and output channel, we have opto couplers. to protect our PLC system from being destroyed by the high voltage from the outside high voltage system. So the output. On output we have the three big categories. The first category is relay. Okay, relay and transistor. And transistor, we talk about this one. And track is new. I'm going to talk about this one a little bit more. And so relay, and the PLC operates electromagnetic relay. Okay, this kind electromagnetic relay. All the relays, they are electrical magnetic, and we use the electrical energy to control the mechanical device. So this is electromagnetic relay. A handle up to a few amps. I just said that's very, very high. Okay, a few amps is definitely very, very dangerous for people. That's definitely very dangerous. Slow response and subject to the wear over time because of relay. Okay, so relay, we have these physical things. We have some contacts. These contacts, when this system is energized, it comes together. When the system is de-energized, they separate. And then after many years, they will be aware. That's a very, very this obvious way. Relay isolates PLC from external the circuit. Also, relay can be used to protect the PLC and used for AC and DC switchings. The control relay can be used for AC and DC switches. So this is the first one. And second one, so control relay, that is a mechanical system, mechanical relay. Right? But here is a transistor, is a solid state relay, solid state things. That can be function as the same as the relay. Used for DC switching. And we have learned two transistors, right? NPN and PNP, right? Okay. And the faster response because solid state need opto isolators and carry loads of 45 amps or less. So this is the transistor type. The triac, as the name suggests, this triac is very, very interesting. When the triac comes into mind, when you see triac, what comes into your mind? 3, right? Triangle, right? So AC means what? Alternating current. So yes, triac is used for alternating current, and it is a triac. Is a triac. This is A2. This is A1. This is triac. So you can see, so this is a triode, okay? This is a sign with a sign of triode. This is diode. The in one direction, this is in another direction. This is called a triac. So used for AC switching, and also this guy needs opto isolators and faster and can carry a load of 0.5 amps or less. Questions regarding these outputs? Questions, yes? No question? And be careful when you handle the relay type. As I said, the few amps is definitely very, very dangerous for us. Ladder programming, because I said this guy is a specialized computer microcontroller, and we need to know how to write a program. So for this guy, we use this is called ladder diagram. It's a ladder, L-A-D-D-E-R, ladder diagram. What is the ladder, guys? What's a ladder? Have you guys used a ladder to help your parents to clean the roof? No? If you know, you should do these things. Okay, ladder means a device that has two legs. Between the two legs, I have multiple rungs, right? Right, guys? I have multiple rungs, so I can climb these rungs to go to the higher this is the position. The same thing here. And so here is a power, and this is the PLC environment, and here this left leg is a power, and the right leg is the ground. Right? And we from very beginning to the very end, we have multiple runs. For each of these runs, we have input, and we have this input, and we also have this output. So this is output. So this is input. So the system run the program from the top to the bottom and from the left to the right. Top to the bottom, left to the right. All right. So if any run does not have any output, you can just simply delete this run. Why? Because this run does not do anything for you. An input, an output. So you can see a run could specify inputs that need to be examined. You examine what kind of condition in this case, the logic that needs to be applied, and the output to be energized. So this is. So here is input, and how these inputs they are arranged together, and what kind of actions they are going to take. They are going to take if some conditions are met. So this is what each run says, and the scan sequence. The system scan inputs from the run, okay, from the run, and solve the logic operation. This is what is logic is, and R, right? So parallel and R. So and R if something happens, and R these kind of things, or XOR. So if something happens, if some conditions are met, then I'm going to do something, take action. So we will do this from the top to the bottom and from the left to the right until we finish all these rounds. I will finish all these rounds and we will have another cycle. So these are methods for input and output process. So the continuous updates. So this is so involve scanning the input channels as they occur in the program instructors input channels. A small delay, 8 microseconds, and so this is used for filter out this background noise for each input to allow the output to occur. Outputs are latched and they remain the state until the next updating. Latched means you want this guy to do something there and you do not change it until next cycle. So here is a method for input and output processing. So okay, so at the start of program execution, all the inputs are scanned and their status is copied into RAM. So first time, so you can mass input. After I scan all these input, I save this in the RAM. Program uses this data for performing logic operation, and output signals are written to the output section of the RAM, okay? Output RAM, and then after the program cycle, the outputs are transferred from the RAM to the output channels. The output latch to this data. Yeah, guys, I can just draw this picture, which is more informative. I'm going to, okay, 2 minutes. I can draw a diagram. So this diagram is more informative for you guys. So this is my internal is the internal memory. And so here is the real output, the real input and output. So here is, I have 3 segments here. So here input image table. Here this one is input image table. So this guy is used to save until this is real input models. Real input model from the signal, or the signal from real input models. Right? So after I finish running, so I have all these outputs. I have output image table, output image table. So this guy, I will control the real output models. Output models. And here is a ladder diagram. So this is a ladder diagram. And this table. You can see this is a mass input and output. All these inputs come into this input image table. After I finish, this is a logic checking all output images table, and will at the same time to drive the different output devices. Questions so far? If no questions, I hope you have a wonderful weekend. So the Sunday evening, 8 o'clock, I will give you the exam 1. The exam 1.